Magandang araw sa ating lahat. Okay, welcome again sa ating course, Microprocessor Systems. And ang topic natin today is the 8051 microprocessor or microcontroller with assembly programming. Before we proceed doon sa ating actual discussion sa 8051 microcontrollers, so let me give you first a background or short introduction about 8051. So the 8051 microcontroller is an Intel-based microcontroller developed in the 1980s na ang primary purpose niya ay gamitin siya for embedded systems. So ano ba itong embedded systems? So by definition, an embedded system can be an independent system, or sometimes we call it a standalone system, or it can be a part of a larger system. An embedded system is a microcontroller or microprocessor-based system which is designed to perform a specific task. So ibig sabihin, pag sinabi nating embedded system, meron siyang hardware in the form of MCU or microprocessor units, meron siyang program embedded in it, and acts as an independent system or as a standalone system. Say for example, a fire alarm is an embedded system which will sense a smoke and will create a sound kapag nakadetect siya ng smoke. So we have several examples of embedded systems like yung detection natin ng temperature na magkakaroon siya ng sound alarm once na mayroon na detect na somebody with temperature na higher dun sa threshold na dinedetect natin. Okay? It could be in the form of appliances or equipment. Say for example, yung ating automatic washing machine na kusang mag-i-stop kapag na-reach niya yung certain time. Kusa rin siya mag-i-stop kapag nag-overload, which is detected automatically by the equipment or by the system kapag gumagana siya. Okay? Pwede rin naman yung mga equipment natin na kusang mag-i-stop or kusang mag-terminate ng kanyang processing kapag na-meet na natin yung maximum allowable load or weight na kinakailangan niya para siya ay mag-perform. Microcontrollers. Okay, ano nga ba ito tinatawag nating microcontrollers or MCU for short? So by definition, a microcontroller is a small computer on a single metal oxide semiconductor integrated circuit or IC chip. So ibig sabihin, pag sinabi nating microcontroller, it's a computer on a chip. So shown below, no, yung mga pictures or images natin dyan, examples of MCUs, the Intel 8051, AVR, or yung tinatawag nating Arduino, which is very popular today. So a microcontroller contains one or more CPUs, yung tinatawag nating processor cores. Meron din siyang memory, and of course, itong mga MCUs na to ay programmable. In short, we are going to create or code a program to be uploaded or to be burned or program or saved doon sa ating MCU para mag-work siya independently.
Okay, so let's continue do sa discussion natin about the 8051 microcontroller. So shown dun sa ating screen is the 8051 microcontroller training board or trainer. Ito yung tinatawag nating training board because this circuit will simulate kung ano yung magiging output ng program na i-upload or i-burn natin dun sa ating MCU. So basically, this training circuit or training board consists of the three main components of a system. So meron tayong input part, meron tayong processing, at meron tayong output. So basically, it's the input, ipaprocess ng MCU, and then magge-generate tayo ng output. Okay, so let's take first yung tinatawag nating inputs. So ano yung mga input ports or input components dito sa ating training board? Okay, so yung switches dito sa baba, which is INT0, INT1, and TO. So dun sa schematic natin or dun sa circuit natin, represented by port 3.2, port 3.3, and port 3.4. I-discuss natin yan in detail sa mga susunod nating discussion, particularly kapag nagkakaroon na tayo or magkakaroon na tayo ng actual programming dito sa 8051 MCU. Okay, so these switches acts as the input part of this training module. Okay, kasi ito yung pipindutin natin or gagawa natin ng program so that kapag pinindot natin yung switch na yan, magki-create siya ng definite output base doon sa pinrogram natin. After ng input, meron tayong tinatawag na process part dito sa ating training module. At dyan mapapaloob yung MCU, which is located dito sa center part ng ating training module. So this one. Okay. Yung 8051 microcontroller, as discussed or as mentioned earlier, dyan natin i-upload or i-save yung program na nagawa natin para siya yung mag-control doon sa entire circuit at ma-generate niya yung intended result or output na gusto nating mangyari. Okay? So we have the input, the switches, and we have the process part, yung MCU, the 8051 microcontroller. So we have the input, we have the process. The next that we have will be the output. So dito sa training module, we have 4 output components or output parts or output devices na pwede natin gamitin or pwede nating magamit para makita or ma-display natin yung output na gusto nating makita or ma-display. So first, yung nasa left part natin, yung LED display. So yung LED display na yan is an array of 8 light-emitting diodes which is connected directly to pin 1 of the microcontroller unit. So pag sinabi natin pin 1, 8 pins actually yan. That's pin 1.0 hanggang pin 1.7. So 8 pins yan. 8 data, single bit data na ipoprogram natin para ma-control natin yung 8 pins LED display or 8 bit LED display. Okay, so saan natin ginagamit yung LED display? Basically, ginagamit natin yan kapag mag-generate tayo ng sequence of light or other applications na kung saan dinidisplay lang natin yung pag-turn on at pag-turn off ng light. Okay, so next is the 7-segment display. So yung 7-segment display naman, ito namang tinuturo ko sa bandang kanan ng ating illustration. So tinawag natin siyang 7-segment kasi yung figure dyan na number 8 ay mabubuo natin using the 7 segments. Kung bibilangin natin, para mabuo yung 8, meron siyang 7 na segments to complete yung buong figure na yon. Pang-8 yung decimal point which is located dito sa lower right portion ng 7-segment display. Okay. The 7-segment display of the 8051 microcontroller training board or training module has 2 7-segment displays. So therefore, this is capable of displaying numbers from 00 hanggang 99. Okay, so saan naman natin ginagamit ang 7-segment display? Ginagamit natin ito para mag-display ng numbers or characters basta kayang i-display nung 7-segment. Okay, so pangatlong output device natin is the buzzer. So basically, ang buzzer ay ginagamit natin para mag-generate ng beep code or ng sound or any sound alarm kapag gumagawa tayo ng isang design na kung saan kailangan nating mag-generate ng noise or any sound as an output. Okay? Say for example, magde-detect tayo ng tao na dumadaan sa isang door. Okay? Kailangan natin ng buzzer para once detected yung tao na nag-pass through doon sa area na chine-check natin, magki-create siya ng sound. Okay. So we have the LED display, the 7-segment, and then yung buzzer. Yung pang-apat na output port or output device na ginagamit natin for this training module is the relay module. So this one, yung colored blue in the upper portion of this training module. So kung titingnan natin, 3-terminal component ito. Okay, we have the common connection. Meron tayong normally open and normally closed. So ano nga ba itong relay? A relay is an electromechanical switch. So napaka-basic ang function ng relay. Nag-a-act lang siya as a switch to open or close a circuit, pero controlled siya electronically using the microcontroller. So in short, hindi natin siya pipindutin manually to turn on or turn off, but we are going to create a program, i-upload natin sa MCU, tapos yung MCU mismo ang magti-trigger whether to turn on or turn off yung device gamit yung relay natin. Okay? So, baka ma-confuse tayo doon sa function ng relay. Ang function lang ng relay ay mag-open or close ng circuit. Okay? Ang kaibahan niya sa typical switch, hindi natin siya manually inoperate. It is operated electronically using a data signal na manggagaling sa ating microcontroller unit. Narito yung mga some of the basic commands or common commands or instructions na ginagamit natin for the 8051 microcontroller. So, napakaraming instructions ito, but I will be introducing some of the most commonly used codes or commands na kakailanganin natin sa programming using assembly language. Okay? So let's start with the ORG or the origin command. So when we say ORG or origin, it is the starting address of the program to be declared at the beginning of the assembly. So in syntax, that's ORG space yung address kung saan magi-start yung programming natin. Okay, so ORG is the command, and then yung first zero doon sa 5-digit zero is a header of the data or the address kung saan tinutukoy natin na magi-start yung ating program. So yung 40H indicates a memory address in hexadecimal format. Since the 8051 is a 64K memory equipped microcontroller, so ibig sabihin ang kanyang memory address ay magi-start from 0000 and magi-end siya sa FFFF. I assume that we are all knowledgeable na doon sa binary operations natin, so we can easily convert binary numbers into hexadecimal numbers kasi in this discussion, we will be dealing with assembly programming. So in short, gumagamit tayo ng different number systems, binary, decimal, even octal sometimes or hexa. But the most common is yung binary at saka hexadecimal numbers. Next is ljmp or long jump. So ano nga ba itong ljmp command? So the ljmp command causes an unconditional branch. So ibig sabihin pag sinabi nating unconditional branch, hindi siya nanghihingi ng kahit anong kondisyon or situation para i-execute yung jump command. Okay? So it causes an unconditional branch or jump to the indicated address by loading the high order and low order bytes of the program counter respectively with the second and third instruction bytes. So the destination may therefore be anywhere in the full 64K program memory address space. So as mentioned earlier, ang memory map natin starts from 0000 hanggang FFFF. So anywhere in the memory of your microcontroller from 0000 hanggang FFFF, the ljmp command has no limitations kung hanggang saan niya pwedeng i-jump yung command kung saan mo siya pinapa-branch or pinapa-jump. Okay, that's ljmp. Wala siyang limitation as to the number of bytes na dapat niyang i-branch or talunin. Kanina mayroon tayong ljmp or the long jump. Okay, so now we also have the sjmp or yung short jump. Anong kaibahan nila? So itong dalawang ito, pareho silang unconditional jump instruction, but this time, a short jump has certain limitations. Okay, anong ibig sabihin nun? The range of destinations allowed is from 128 bytes preceding this instruction and 127 bytes following it. So kung titignan natin dito sa illustration, say for example, sa memory address 0003H, nag-execute tayo ng sjmp FFFDH. Okay? So kung bibilangin natin yung bytes from 0003 papunta doon sa FFFB, it exceeds yung limitation natin na 127 bytes. So in short, if we created a program or an instruction using this sjmp FFFDH papunta dito sa FFFD address, magkakaroon tayo ng error sa ating program kasi magiging out of range yung address kung saan mo siya pinapatalon or pinapabranch. Okay? So, anong dapat nating tandaan dito? If we are going to use short jump, take note that the address should be 128 bytes preceding the instruction or 127 bytes following yung sjmp instruction natin. Next is MOV or the move command. Okay, ano nga ba itong move command na to? So, MOV stand for move byte variable. Pag sinabi natin move byte variable, we are going to copy a certain data from one location to another or from one register to another. Okay, so the byte variable indicated by the second operand is copied into the location specified by the first operand. So take note, meron tayong mga tinatawag na data handler kung saan kayang mag-store ng 8-bit data. Pag sinabi natin 8-bit data, ang example niyan, R0, which is a register 0, kaya niya mag-store ng 8-bit data like 0011, 0000. So this is an 8-bit binary number na kayang i-store sa mga registers na tinatawag natin. Okay, paano nagpa-function yung move command? So we have several examples here. Say, in the first line, move R0, number sign 30H. Okay, anong ibig sabihin nitong command na to? Okay, the MOV for move and then R0, number sign 30H. Anong ibig niya sabihin? So lagi nating tatandaan that the first operand is R0. Okay, yung R0 natin is the destination followed by comma, and then number sign 30H, the second operand could be a data or a register na kung saan yung laman ay ikakopy natin doon sa destination. So in short, MOV is the command or instruction, RO is the destination, and then number sign 30H is the data or the source of data na ilalagay natin papunta sa destination. Okay, so kapag in-execute ng 8051 yung move R0, number sign 30H, ang magiging laman ng R0 is 30H, which is if we are going to convert it into binary, this is equivalent to 0011, which is 3, 0000, which is equivalent to 0. So this one is 30H in hexa. Okay. So yung first line natin, move R0, number sign 30H, this is a direct data or the actual data copied to R0, which is a register. Okay, ilalagay natin yung 30 hexa sa loob mismo ng R0. Okay, so next is move R1, A. Ano nga bang ibig sabihin ng move R1, A? So this code is actually a register-to-register move command. Anong ibig sabihin ng register-to-register? Pareho silang data handler, which is register 1, and then A, which is known as the accumulator, also an 8-bit register, na kung saan yung laman ng A, which is magsiserve siya as source, ay ikakopy doon sa R1, na ang R1 natin ay magsiserve as the destination. So in short, yung laman ng A will be copied doon sa R1. Okay, so after the execution of move R1, A, R1 will be equivalent to A. Okay? Bakit? Kasi yung laman ng A, ilalagay natin sa R1. So in short, si R1 is equivalent to RA. So the question is, bakit hindi nawala yung laman ni A? Okay? Because a move command is a non-data destructive command. So gaya ng sinasabi ko, we are going to copy the content of the source register papunta sa destination register. So kung ang laman ni A is 7 at kinapi mo siya sa R1, ang laman ni R1 ay 7 also at mariretain yung 7 kay A. Okay, pero kung si R1 may dati siyang laman, what will happen if we are going to move A papunta kay R1? Okay, yun yung tinatawag naman nating destructive. Bakit? Kasi whatever content or data na mayroon si R1, pagka-execute natin ng move, marireplace na siya nung laman ng A. Okay. So the last one is move P2, P1. So just the same with the second example natin. P1 is the source register or source port. P2 is the destination port. So whatever data na nalagay natin sa P1 will be copied to the P2. And after the execution of this code, P2 will have the same value with P1. Okay, next is lcall or yung tinatawag nating long call. Okay, lcall stands for long call. It calls a subroutine located at the indicated address, and the subroutine may therefore begin anywhere in the full 64 KB program memory address space. No flags are affected. So, kung titignan natin yung diagram natin, lcall FFFDH, okay? Pag in-execute natin yung lcall FFFDH, hahanapin niya yung address na to, which is here, and then mag-call command siya. Okay? Kung mapapansin natin, kapareho lang siya ng ljmp. Okay, so what makes it different from ljmp? Okay, pag sinabi nating lcall, tatalunin lang niya yan para i-execute and it will return back doon sa next instruction. Pero kailangan niya ng ret command, which is yung tinatawag nating return. So sa ljmp or sjmp, once na tumalon yan doon sa memory address na yon, hindi na yan babalik doon sa pinanggalingan niya, not unless ipapa-jump mo siya doon sa address na nasa dati niyang pinanggagalingan. Okay? So sa lcall, ito ang kaibahan niya sa ljump. Si lcall, pag in-execute natin si lcall, i-resume niya yung next instruction na kasunod, say lcall ffdh, and then meron kang another command dito. Pag natapos niyang in-execute yung command dito, at nabasa niya na yung return, okay? Babalik yan doon sa kanyang pinanggalingan para ituloy yung naantala or na-stop niyang operation. Okay? So that's the lcall command. Okay? Next is acall or absolute call. So kung meron tayong ljmp kanina, and we also have the short jump, so si long call at si absolute call is just the same or parang counterpart siya ng ljmp and sjmp. So si absolute call or acall unconditionally calls a subroutine located at the indicated address. So the subroutine called must therefore start within the same 2K block of the program memory as the first byte of the instruction following the acall. Okay? So the effective range of acall ay 2 kilobytes lamang. Next is DJNZ, or yung tinatawag nating decrement and jump if not 0. Okay, kung titignan natin, this is another variation of jump command, pero this time, the DJNZ is a conditional jump instruction. So pag sinabi nating conditional jump, meron tayong isa-satisfy na condition para i-execute niya yung jump command. Okay, so ulitin natin, decrement and jump if not 0. So ibig sabihin, i-decrement niya yung particular value and then mag-execute siya ng jump if yung value na dinecrement niya ay hindi pa 0. Okay? So let's make it clear. Babawasan niya ng isa yung value. Ang ibig sabihin ng decrement. Okay? Pag dinecrement natin ang 10, magiging 9. We will decrement 9, magiging 8. So it's a -1 operation na ginagawa ng microcontroller. Okay? So habang nagde-decrement siya, i-check niya ngayon yung value ng dinedecrement niya at gagawin niya yung jump every time na yung current value is not 0. So in short, any value basta hindi 0. I-execute niya yung jump. Okay. So the DJNZ decrements the location indicated by 1 and branches to the address indicated by the second operand if the resulting value is not 0. So an original value of 00H underflows to 0FFH. Okay? So, nabanggit ko kanina that the registers or data handlers sa microcontroller natin ay 8-bit registers. So in short, they are capable of handling 00, which is 8 zeros in binary, hanggang FF, which is 8 ones in binary. Okay, so let's say we have two registers, R0 and R1. So ginamit natin ito as a representation of values na ilalagay natin sa dalawang register. And then we will use the DJNZ para makita at maintindihan natin paano gumagana yung DJNZ. Okay. So by the way, 00H is equivalent to 0 in decimal, and then FFH is equivalent to 255 in decimal. So mas madali kasi tayo magkaintindihan if we are dealing with decimal numbers, kasi madali tayong mag-subtract kapag nagde-decrement tayo using decimal numbers. Okay. So, on the lower left portion of the screen, nakalagay dyan yung delay function na ginagamit natin kapag nagpo-program tayo. Okay, para saan ba yung delay? Ang mga computers natin or mga microcontrollers, nag-execute yan ng commands in a matter of microseconds or milliseconds. Okay? So, halimbawa na lang, the 8051 microcontroller is operating at 12 megahertz, for example, frequency. Okay, 12 megahertz is equivalent to 12 million cycles per second, hypothetically. So in short, kung magpapa-blink tayo ng LED, magbi-blink siya ng 12 million times in 1 second. So just imagine, kaya pa ba ng naked eye natin na makita yung pagta-transition from on to off and off to on ng LED kung ang gagawin niyang on and off sequence ay 12 million in 1 second. So napaka-imposible na makita na natin yon. So baka ang nakikita na lang natin ay naka-steady ilaw na LED. Pero alam natin as a programmer na nagbi-blink yon. Sobrang bilis nga lang to the point na hindi na natin kayang makita gamit yung ating mga mata. Okay, so para maiwasan yon, gumagamit tayo ng tinatawag na delay. Ano itong delay? Ito yung subroutine or program, a small portion of a program para mag-waste ng time. Okay? Paano siya mag-waste ng time? Gamit itong DJ and say function. So let me elaborate yung discussion natin kanina about DJ and say or yung decrement and jump if not zero. Okay, so DJ and say, so ang ibig sabihin nga nito, di ba? So decrement and then jump if not zero. Okay, so basically, ang ibig sabihin ng DJ and say, i-decrement mo yung particular value and then magja-jump ka doon sa in-specify niyang address if yung register na dinecrement mo is not equal to 0. Okay, so ito yung program. So this is the delay program and then move R0, comma, number sign 0, FFH, and then sa loop 1, we have move R1, comma, number sign 0, FFH, and then loop 2, we have DJ and Z R1, comma, I know. Loop 2, and then DJ and Z R0, comma, loop 1. Okay, so we have here a delay program. Okay, gaya ng sabi ko kanina, ginagamit itong subroutine or small program na to para mag-execute lang ng time delay or mag-waste lang tayo ng time para makita natin yung output bago siya maglabas ng panibagong output. For what reason? Kasi ang ating mga microcontroller, ang ating mga microprocessor ay nagpo-function or nag-execute ng command in a matter of micro and milliseconds. So sabi ko kanina, yung 8051 na 12 megahertz frequency, it has the capacity to perform 12 million instructions in a matter of 1 second. So ganun kabilis, hindi natin kayang makita in a blink of an eye or hindi natin kayang tignan using our naked eye yung magiging output ng LED if 12 million transitions ang gagawin niya in 1 second. Okay, so paano nagpa-function or paano gumagana yung DJ and say command? So sabi ko kanina, so we have two containers. Okay, that's R0 and R1. Okay, let's say this is R1 and this is R0. So paano ginagawa yung program na yan? So sabi niya rito, move R0, comma, number sign 0FFH doon sa delay line. So this one. Pag ina-execute ng computer or ng controller, yung function na yan, okay, ganito ang ginagawa niya. Yung R0, lalagyan niya ng FF. Okay? Lalagyan niya yan ng FFH or in decimal, gagawin niya yung 255. Okay? You can use your calculators para i-verify. Kasi ang equivalent value ng FF hexa ay 255 decimal. Okay? So, itong line na to, itong delay line na to, maglalagay tayo ng FF or 255 sa loob ng R0. So, ito, ginawa na natin. So, tanggalin ko na yung 255 para madali nating maintindihan. Yung FF, let's use the decimal kasi madali nating maintindihan kapag decimal. Okay. So, next, pagkatapos ma-execute si delay, mag-execute siya sa loop 1. So, anong gagawin ni loop 1? Move R1 number sign 0 FFH. Just the same. Lalagyan natin si R1 ng 255. Okay. So, si R0 and R1 ay meron ng 255 na value respectively. Okay. Tapos na si loop 1, i-execute natin yung command sa loop 2. So, anong gagawin dun sa line na yon? Decrement R1. Okay. Pag dinecrement natin si 255, magiging -1. Ang current value niya is 254. Okay. And then, ano yung condition? Magja-jump tayo sa loop 2 if R1 is not 0. Okay? Ang ibig niyang sabihin, dito yung yung initial function niya or initial execution niya, magja-jump daw tayo sa loop 2 if R1 is not 0. Okay? So, basically, masasagot natin yan ng true kasi ang laman ni R1 ay 254 which is not 0. So ang gagawin, dahil true yung sagot natin dito, susundin natin tong function na to. Okay? Susundin natin yung function na yan. Tatalon tayo or mag-execute tayo sa loop 2. Paulit-ulit yan, paulit-ulit siyang magpa-function dito hanggang hindi niya nagiging false or hindi niya na mimit yung not 0 or yung 0, I should say. Okay? So, ilang beses? Ilang beses mo bang i-decrement ang 255 para maging 0? So, in short, 255 times kang magma-minus para ma-meet mo siya sa 0. Okay? So, assuming nakailang rounds na siya. Okay? Halimbawa, 1 na lang siya. Ang current value ni R1 ay 1. I-execute natin ulit si loop 2. Okay? Decrement R1 from 1 minus 1 magiging 0. Okay? The next function is mag-jump tayo sa loop 2 if R1 is not 0. Dahil si R1 is now equivalent to 0, etong function na to is already false. So, ibig sabihin, kapag false na siya, hindi niya na i-execute itong function na to. Okay? Dahil false na siya, ang next niyang i-execute ay itong function na djnz R0 loop 1. Okay, so ano nang nangyari? So dahil naging 0 na ito, okay, ang current value niya ay 0, i-execute natin ngayon ito, ganito ang mangyayari. Decrement R0, si R0, 255 minus 1, magiging 254 na lang siya. Okay? And then, jump daw tayo sa loop 1 if not 0. Okay, this time naman, ang tanong dito, magja-jump tayo sa loop 1 if R0 is not equal to 0. Okay. So, dahil 254 yan at hindi siya equal to 0, true itong function na to. True pa siya. Okay. At kapag true siya, susundin natin kung ano yung pinapagawa niya. Magja-jump tayo sa loop 1. Okay. So, ang value niya is 254. Okay? Dahil 254 na siya, susundin natin, magja-jump daw tayo sa loop 1. Etong loop 1 ngayon ang i-execute natin. Okay, anong pinapagawa ni loop 1? Move R1 FFH. Lalagyan ulit natin si R1 ng 255. So, yung naubos na 0 kanina or naubos na 255 which is naging 0, kakargahan mo ulit ng 255 kasi yun yung function na nakalagay sa loop 1. Okay. So, dahil naging 255 siya, ang susunod na naman nating execute is loop 2. Okay, uulitin na naman natin yon. I-decrement mo si 255, okay, minus 1, magiging 254 ulit. Paulit-ulit kang iikot ulit dito hanggang sa itong R1 na yan ay maging 0. Okay, pag naging 0, magma-minus 1 ka na naman, magiging 253. Okay, lalagyan mo na naman ito ng 255. Okay, uubusin mo na naman siya hanggang sa maging 0. And then pag naging 0, minus 1 na naman, magiging 252. Ay, sorry, magiging 252. And then lalagyan mo na naman ito ng 255. Okay, so ano ngayon ang magiging end result? Pabawas ng pabawas ito 1 by 1 and then inuubos natin to. So we could assume, okay, at a certain amount of time, magiging 0 ang value nito, magiging 0 ang value nito. Okay, at kapag naging 0 si R1 at R0, etong statement na to ay magiging false, this statement ay magiging false, wala na siyang tatalunan doon sa delay function na yan. Yung susunod na instructions na dito, yung i-execute niya. Okay? So dito na ulit yung next command na naka-program doon sa ating assembly program or naka-code doon sa ating assembly program. Okay? So as mentioned earlier, ang function lang nitong program na to ay mag-waste ng time. Okay. Ang purpose niyan is to waste time para makita natin yung transition ng LED from 1, which is on, papunta ng 0, which is off. Okay? So just imagine, in a microcontroller or microprocessor, kailangan natin mag-waste ng time kasi pag pinablink natin ang LED in a matter of microsecond, we can no longer see kung ano ba yung pagpapalit ng value ng LED. Okay? So that's basically the function of DJ and Z. Okay? De-decrement natin yung value. Let's check if it is not equal to 0. Pag hindi siya equal to 0, then execute. Okay? Pag nag-equal to 0, we will execute the next command na susunod doon sa function na yan. Okay, so I hope naging clear sa atin yung discussion natin about DJ and Z. Okay, ito na yung tinatawag kanina na na-touch ko na ito kanina, yung RET or the return from subroutine. Okay, so ret pops the high and low order bytes of the program counter successively from the stack, decrementing the stack pointer by 2. Okay, so program execution continues at the resulting address, generally the instruction immediately following an A call or L call. Okay, so simplihan natin. So dito sa memory map natin, meron tayong L call, FFFDH. Okay? Kapag in-execute natin si L call from 0003, tatalon siya doon sa address na to, which is FFFD. Okay? I-execute niya whatever command ang nandyan. Pwedeng multiple lines yan. Okay? And then, doon papasok si return command para makabalik siya doon sa next instruction bago siya tumalon. Okay, that's the mere purpose of return. Para makabalik yung pointer natin doon sa next instruction following the L call command. Last but not the least, yung END or the end of assembly. So, it stands for end of assembly and we are required to always put an end after coding the assembly. So, sa C language, alam ko familiar kayo, meron tayong open parenthesis para mag-start tayo ng isang particular function and then meron tayong close parenthesis para i-terminate or i-end yung isang instruction. So in the same way, sa assembly programming, meron tayong ORG or the origin which is represented by this one in C. Okay? Ito naman, nire-represent siya ng end. Take note na kapag gumagawa tayo ng assembly program, we always starts with the origin command stating kung saang address tayo mag-start and then we will end the assembly using the end command. Okay, otherwise magkakaroon ng error or hindi mag-execute yung ating program. Okay, that's the end of our discussion about the 8051 microcontroller. So na-discuss ko na from the basic parts ng ating training module or training board and then yung mga input components, yung ating processor at saka yung ating mga output components which is bumubuo doon sa sa ating training board. So ipo-program natin 'yan using the assembly language, i-upload natin sa MCU, and we will simulate it using this training board, or if not possible, we will use the simulation software like the Proteus or other simulation applications available online. Okay, so I hope na touch natin yung mga important and essential topics about 8051 microcontroller. So I will be recording another video for the actual applications. So magsisend ako sa inyo ng file kung saan meron na tayo doong ready-made circuit, and we will try to simulate. We will try to code a program, upload it into the microcontroller, and we will simulate using this training board. Okay, so see you again in the next discussion. Thank you.